Om Swastiastu. Assalamualaikum warahmatullahi wabarakatuh. Shalom Namo Buddhaya. Hello everyone, welcome back to my YouTube channel. In this video, I would like to tell you about metals and alloys with my lecturer, Profesor Dr. Tjokorda Gede Tirta Nindhia, Sarjana Teknik Magister Teknik with NIP 197 201 161 998 031 004. Let me introduce myself. My name is Nyoman Satria Dharma Cahadi. You can call me Satria with name 220-553-1159. I'm from Udayana University with Engineering Faculty, take Mechanical Engineering Department. My literature search for this video is book Science of Engineering Materials, Volume 2, Materials by Chanda. There are table of contents of this video. First, alloy steels. Second, tool steels. Third, cast iron. And fourth, wrought iron. First, alloy steels. This is the alloying elements diagram. From that diagram, we know the effect of alloying elements. These are the effect of alloying elements. Manganese steels, or Mn. Manganese is added to all steels as a deoxidizer and isn't considered as an alloying element if it is less than about 1%. As an alloying element, manganese contributes largely to strength and hardness and has a moderate effect on hardenability. Fine-grained manganese steel are characterized by a combination of high strength and toughness. This steel therefore find use in the manufacture of gears, shafts, axles, and revolve barrels. Nickel steel, or Ni. Nickel is one of the most important elements added to steel. It has unlimited solubility in austenite, both being FCC or phase center cubic and also dissolved to a considerable extent 25 to 30% in ferrite, increasing the strength and toughness of this paste. Nickel steel are highly suited as low alloy, high-strength structural steels, which provide better mechanical properties and corrosion resistance than can be obtained from low-carbon structural steels, though both are closely related. Chromium steels, or Cr. Chromium is the most common of the carbide-forming elements. Low alloy steels contain as little as 1% chromium. In steels with low carbon content, chromium tends to go into solution in ferrite, thus increasing the strength and toughness of this paste. Chromium steel with medium carbon content can thus be hardened by a quench in oil and are said to be oil hardening. These steels are used for spring, engine bolts, studs, axles, etc. Nickel chromium steels. Nickel chromium steels are combined the properties of both nickel steels and chromium steels. The weight ratio of the two alloying elements, nickel and chromium, in this steel is approximately 2 nickel and 1 chromium. The medium carbon nickel chromium steel, which can be usefully hardened to form martensite, are used for automotive connecting rods and drive shaft. Molybdenum steels, or Mo. Molybdenums are relatively expensive element, is a strong carbide former. It improves the high temperature hardness and strength of steels. Due to the presence of molybdenum carbides, some steels are able to retain hardness even when red hot. Molybdenum is thus used in hot working steels such as forging die steels. This element is, however, used mostly in combination with both chromium and nickel, Cr and IMO steels. The hardenability of chromium and nickel steel with medium carbon content is very high. Vanadium steels, or V. Vanadium, an expensive alloying element, is a strong carbide former and an inhibitor of grain growth. It thus promotes fine grain condition and addition of as little as 0.05% vanadium, producing a uniform fine grain casting. With medium carbon, these steels have high strength and toughness and are used for spring, engine bolts, axle, etc. Tungsten steel, or W. Tungsten is like molybdenum, is a strong carbide former, has a strong effect on hardenability and retards the rate of softening of martensite on tempering. Quantities of tungsten required to produce the desired effect are, however, relatively large, roughly 2 to 3% tungsten being equivalent to 1% molybdenum. The main use of tungsten is in tool steel. Silicon steel, or Si. Silicon, like manganese, is used in small quantities in all steel to act as a deoxidizer. The formation of this solid solution distorts the phase lattice, and the metal consequently show bigger tensile strength, higher hardness, and reduced ductility. Silicon steel used for spring and also for C-cells and punches. Stainless steel. Stainless steel are the most important ferrous alloy that resist corrosion. They are also well suited for bead-resisting application since they are resistant to corrosion by oxidation and have fairly good strength at temperatures up to 600 Celsius. Stainless steel contain chromium and nickel, or chromium, nickel, and manganese as the principal alloying elements. Austenitic stainless steels. Austenitic stainless steel are essentially chromium nickel iron alloys. The addition of nickel improves certain aspects of corrosion resistance of chromium alloys. The austenitic stainless steel are essentially non-magnetic but may become slightly magnetic due to the formation of ferrite as a result of cold work. Second, tool steels. Tool steel can be classified into 7 types. They are W, O, A, S, H, T, and M. The application of type W are woodworking tools, blade, constraint breakers, or etc. The application of type O are taps, solid threading dies, bar and tubes, or etc. And the application of type A are thread rolling and slitting dies. The application of type S are reverse sets, punches, chisels, or etc. The application of type H are hot extrusion dies or hot forging dies. Last, the application of type T or M is high-speed cutting tools. Third, cast iron. Gray cast iron. Gray cast iron is the commonest type of cast iron containing 2.5 to 4% carbon and 1 to 3% silicon. The graphite is formed by the decomposition of cemented according to this reaction. Because of these graphite flakes on this picture, First, difficulty in welding of gray cast iron. Second, low tensile strength. And third, has low ductility. The properties of gray cast iron. First, having high fluidity at casting temperatures and low shrinkage. Second, the network of graphite flakes provides a considerable degree of corrosion resistance. Third, gray cast iron is readily machinable due to the lubricating action of graphite. Fourth, gray cast iron thus has excellent damping capacity and is often used as a base for masonry or any equipment subject to vibration. The application of gray cast iron are furnace door, gear, elevator door, or etc. Okay, we move to nodular cast iron. Nodular cast iron is produced by inoculating the liquid cast iron when it is poured from the melting furnace or cupola with a small amount of magnesium. This treatment causes rapid precipitation in a nodular or almost periscal form. The graphite nodules also serve to lubricate cutting tools and thus provide high machinability to nodular cast iron. The properties of nodular cast iron: first, doesn't produce stress concentration. Two, has a much greater ductility. And third, has a higher tensile strength than exhibited by a gray cast iron. The application of nodular cast iron are crankshaft, tractor parts, and dozer. White cast iron. To produce this white cast iron, which contain carbon in combined form as cemented, the total carbon content is kept between 2.0 and 2.5%. The silicon content below 1%, and the casting is cooled rapidly by such methods as the use of stellar graphite insert in the mold. The property of white cast iron are: first, white cast iron is extremely hard. Second, has a abrasion resistant. Third, unmachinable and unweldable. The application of white cast iron are extrusion nozzle, ball mill, and cement mixer. Malleable cast iron. Malleable cast iron is produced by a special heat treatment of white cast iron, namely heating at about 950 Celsius for nearly 50 hours followed by slowing cooling, which causes cement to decompose to ferrite and carbon or graphite in the form of rosette or cluster embedded in the ferrite matrix. Because of this microstructure, the metal has much improved ductility or malleability, and hence the name malleable cast iron. The property of malleable cast iron are: has tensile strength 5800 until 6500 psi, has yield point 4000 until 4500 psi, has elongation percent in 15 until 20%, has BHN 135 until 155. The application of malleable cast iron are manhole cover, railroad, and pipe fittings. Last, alloy cast iron. Alloy cast iron, as the name signifies, are produced by adding to cast iron suitable alloying elements such as nickel, chromium, silicon, copper, molybdenum, and vanadium. The elements are added to cast iron for improving its mechanical properties, heat treatment characteristic, and resistance to corrosion, heat, or wear. Fourth, wrought iron. Wrought iron is essentially a composite material consisting of high purity or alpha iron and slag. Because of that, the carbon content of the iron is generally below 0.08%, the manganese content below 0.06%, and the slag content usually varies between 1 and 3% by weight. Okay, that's all about metal and alloys. Thank you for your attention and thank you for watching my video. See you guys.